On this edition of MC Gen Chem, Chemical Structure and Modeling, there are some rules to follow when you are drawing chemical structures. First, you must write the correct formula. Second is to count up the total number of valence electrons in the molecule. Third, the least electronegative atom goes in the center, except for hydrogen. Fourth, place single bonds connecting the outer atoms to the inner atom. Fifth, fill up the octet by making double or triple bonds as needed, or by adding lone pairs to the electrons. First, we are going to draw ammonia. The formula for ammonia is NH3. Looking at your periodic table, you will see that nitrogen is in the fifth column, which means that it contains 5 valence electrons. Hydrogen only has 1 valence electron, but since there are 3, you have to account for all of them, making the total number of valence electrons for ammonia to be 8. Then, draw your atoms, with nitrogen in the center and the 3 hydrogen atoms surrounding it. Now we must make single bonds from the hydrogens. This accounts for 6 electrons from the single bonds, so to fill up the octet, you must add a lone pair of electrons. The geometry of this molecule is tetrahedral, and the shape is trigonal pyramidal. The bond angles for a tetrahedral molecule are typically 109.5 degrees. Since this molecule has a lone pair of electrons, this will push the bonds down, making the bond angles smaller than 109.5 degrees. Next, we will look at drawing methane. The formula for methane is CH4. Looking at your periodic table, you will see that carbon is in the 4th column, which means that it contains 4 valence electrons. Hydrogen only has 1 valence electron, but since there are 4, you have to account for all of them, making the total number of valence electrons for methane to be 8. Next, draw the atoms, with carbon in the center and the hydrogens surrounding it. Since there are 4 single bonds, this accounts for all 8 valence electrons and fills up the octet. This molecule has a tetrahedral geometry with a tetrahedral shape. This means that the bond angles for this molecule should be 109.5 degrees. Here is an example of the previous 2 molecules built using a molecular model kit. On the methane, you can see the center black ball representing carbon and 4 gray balls representing hydrogen, with pink bonds connecting them, representing single bonds. The NH3 has a dark blue center representing nitrogen, 3 gray balls representing hydrogen, connected with pink single bonds. Also, the green tab on the top represents the lone pair of electrons. For the next part of the experiment, you will be using a software called Avogadro. I will be showing you how to make CH4 or methane. Once Avogadro is open, you are ready to draw. Make sure the Draw Tool button is selected. This is the pencil icon. Choose the atom you want to make your center atom from the drop box. If the Adjust Hydrogens button is checked, then make sure you uncheck it. Click on the black empty screen and your atom will appear. In this case, carbon is dark gray. Now we want to add our hydrogens. Go over to the drop box and choose hydrogens and single bond. Click and drag from the center atom out. Do this 4 times to account for all hydrogens and valence electrons. Now that our molecule is drawn, we must make sure that our energy is optimized to the lowest possible energy state. Click the button that looks like an E with an arrow underneath it. Make sure both boxes are checked and click Start. Once the molecule is done optimizing, click the Stop button. Now we will measure the bond distance and angle using the tool that looks like a ruler. Click on this tool and click on 2 atoms to measure the bond distance and 3 atoms to measure the bond angle. As you can see, I am measuring the bond angle. After clicking on 3 atoms, I can see that the bond angle is 109.5 degrees. We know this is correct from what we previously learned about tetrahedral geometry and shape.